So we'll start then total. Okay. Then listen to the board. Then we'll write some few points. First part, what we have learned using mirrors. Then we learned about refraction. So there is a transition from reflection to refraction or refraction to reflection. So critical angle refraction, when to happen reflection. For example, this is an incident ray, right? So this is called angle of incidence. If the incident ray is coming along the normal, then angle of incidence is equal to what? 0. Now it has angle of incidence will have one value. Now I increased the angle of incidence this much. Okay, I can further increase angle of incidence this much. So angle of incidence, this is for example, this is I1 and this is I2 and this is I3. So if you are increasing the angle of incidence beyond a certain value, then what will happen? The ray will, here I know I3 greater than I2 greater than I1. Correct. So I1 is the smallest angle. If you give I1, then the fraction. If you are giving I2, for example, at some surface, if you are further increases, what will happen? This will be getting reflected back. So this is like 1, 2, 3. First case, refraction. Second case, gray surface. Third case, if you further increase, reflected back. Okay. So I1 is given, it is what is happening here? Refraction. When I2 is giving, what is actually happening here? Still there is refraction, but the angle of refraction is equal to 90 degree. Okay, but if you are giving I3, then there is no angle of refraction, but instead what is coming to picture? Angle of reflection. Angle of incident is equal to angle of reflection. That is law of reflection. Correct? So I1, I2, I3, if you are giving I1, it will undergo refractions with an angle of R. If you are giving I2, the ray will be 90 degree. If you further increases, then what will happen? It will be get reflected back, and the reflecting angle is same as angle of incidence. That is called a law of reflection. So here I can apply law of reflection, but here I can apply Snell's law because it is refraction. So here it is refraction, here it is reflection. Is a refraction. Both 1 and 2 is a refractions. Here refraction angle is less than 90, but here refraction angle is equal to 90 degree. Correct. But here it is law of reflection. So law of reflection is there. Law of refraction either less than 90 or equal to 90 degree. Okay. So what is critical angle? Is the angle at which here I2 I can call critical angle, because if you are giving I2 is the angle of incidence, the ray will be undergo what is called a 90 degree refractions. So the refracting angle is equal to 90 degree. That particular angle of incidence is called critical angle. Okay, so I can say I2 is critical angle is representing C, but I know I1 is less than I2. Correct? I1 is less than I2, so I can say I1 is less than critical angle. One case. Another case, what I can written as I3 greater than critical angle. When I2 equal to C, than critical angle. will angle, ray will undergo this is the interpretation. Okay, now I want, so these two, I don't know what is I1, what is I2, these things I don't know, but here I have some information. Moving from denser medium to rarer medium, this is the conditions to happen total internal reflection. So moving from denser medium, refractive index I am giving as n, for example, n, and this is a rarer medium considering like air with a refractive index equal to 1. So from denser to rarer it is moving. Angle of sine I, second case I2. So what? Air medium. Okay. Of refraction is how much? 90 degree. So equal to 1, we can written as sine critical angle equal to sine inverse of 1 by. So this is the definition of critical angle. Okay, formula is important, of course formula is important. So I can say C is equal to sine inverse of 1 by n I have written. Here 1 means actually for a, 1 means actually for what? Refractive index of the rarer medium, and n is the refractive index of the denser medium. So I can say critical angle is equal to sine inverse of refractive index of rarer medium divided by refractive index of denser medium. This you have to remember because this we are going to use in the formula. Okay, the rarer medium is, it is not necessary it should be always a, the refractive index, here only this is applicable, else this is not applicable, divided by refractive index of the denser medium, provided the ray has to move from where to denser to rarer. Understood? We will write all these points. First point, right? Angle, right? Critical angle at which critical refracting is equal to 90 degree. Refracting angle is equal to 90 degree. That is called critical. Okay. Number 1, I less than critical angle. Less than critical angle. What will happen? Refraction will angle. But then we'll draw a diagram, normal ray like this. We have to mark this is a denser medium, to rarer medium. I is less than C, refractions will happen. Number 1. I less than C, refraction will denser to rarer medium. Okay. Number 2. Number 2. I is equal to critical angle. Number 2. I is equal to critical angle. Refractions will happen. Again refraction. But right, refractions will happen, but ray is grazing over the surface, grazing over the surface to 90 medium to rarer medium are equal to 90 degree. Then move to the third one. Critical angle. I greater critical angle. Incident ray greater than reflection. Critical angle. Reflection. Then below, right, at critical angle, next point, at critical angle, Snell's law, at critical angle, according to Snell's law, N1 sin I equal to N2 sin R. Then N into, you can write. You don't write I, you can write it as I itself. You sin 90. Then sin C equal to 1 by n. C is equal to sin inverse of 1 by n. C denser medium. This is important. Remember, C is equal to sin inverse of, or sin C is equal to refractive index of the rarer medium divided refractive index of the. Okay, then write one question. Right question. Complete the ray diagram. Complete the ray diagram. Complete the ray diagram. Path we need to refer. Complete the ray diagram. Here C equal to 42 degree. Here C is equal to 42 degree. Here C is equal to 42 degree. Critical angle is given 42 degree. incident ray, you have to find how it is going, how it is after hitting here, what will happen. Okay, you have to complete the ray diagram, which means critical angle is given 42 degree. You have to say what is happening, how the ray will be undergo reflections and all. How it will go? Here we will do the normal. Okay, so angle of incidence is how much will be here? This angle, right? 48 degree, correct? Total 90 degree will come. You have to draw in a separate diagram, don't mark it in the same question. Okay, answer. Listen first, then we'll do. So 48 degree. So what will happen? Angle of incidence greater than critical angle. So what will happen? It will undergo reflection. So it will undergo reflection. 48 degree. Okay. Next we have to see what will happen. Okay, now we have to calculate this angle. If you extend these two lines, both are meeting at some angle. So this is 90, this is 48. So of course this is what again? 42 degree. 42 degree. Now angle of incident is equal to what? Critical angle. Ray will go refraction, reflection, grazing. Grazing. So ray will be passes through like this. Okay. And the logic. There is passes through like this. You want to know how ray diagram, because we'll use in many questions like this too. Mostly you will get one question from this area. Percentage you will get one question. They will not ask you to complete the diagram. They will give you some parameters. For that you want to know how to draw the diagram. Based on the diagram you are getting, you have to apply something and you have to find it. Okay, but this is the fundamental. Question and answer should be separated. Do not throw it in the same diagram, because question is that much, answer is this one. Answer okay, both should be separate. So this is understood. Every point we have to analyze whether we are equal to or greater than refracting angle. Then the next question. Complete the ray diagram. Complete the ray diagram. Critical angle, with critical angle equal to 42 degree again, with critical angle equal to 42 degree. With critical angle equal to, complete the ray diagram, how it is moving, how the ray will go. It is entering to a kind of prism. Surface we have to analyze, then what will happen we have to see. Render will happen likewise. But no formula, nothing is required, only angle calculations. Complete. Here angle of incidence is how much? 0 degree. So angle of refraction is also, angle of incidence is 0 degree. So that is less than critical angle. Less than critical angle? Yes. So the ray will undergo refraction. It will enter to the next medium like that. Now you got hint, right? There you confused, huh? Nothing will be there. Here angle of incidence that is less than critical. Ray will enter. After entering, it will hit. You have to draw some triangles and you have to calculate what is happening here. Then again you see that angle is equal to critical angle or greater than critical angle or less than critical angle. If it is less than critical angle, what will happen? Refraction equal to critical angle. Greater than critical angle, total intelligence means same. Immediately return with the same angle of incidence equal to angle of refraction. Whatever we have learned, we are applying in a question. That's all.
Past assumptions.
This is correct. This is return.
Triangles.
Okay. Got it up? 0. Angle of incident is equal to 0 means 0 is less than critical angle. Ray will undergo refraction. But angle of refraction, ray will undergo refraction. But what will be the refracting angle? 0. Because if refraction will be there, you can apply Snell's law. Of course, you can apply Snell's law. This is N. So applying Snell's law, sine of 0 n into sine of r. So sine r equal to 0, r equal to 0. So this ray will go like this straight. Okay. Now we have to calculate. Normal. Okay. This 45. What is this? 45. Now angle of is what? 45 degree. Angle of incidence is greater than critical angle. So ray will undergo reflection. Reflection means this should be equal to angle of reflection. So I know this total angle is how much? So now this angle is with normal. Total.
Refraction, but again I'm getting 45 minutes.
This refraction is not correct. Refraction should be straight forward. How you get to this refraction? If you give this refraction, see this is a normal ray. According to your refraction, angle of incident is equal to 0, but angle of refraction will be here. That is possible? Not possible. But the angle of incidence 0 means refraction is also 0. So ray will go straight. No. Okay. Next question. Complete the ray diagram again. With the critical angle equal to 42 degree. With critical angle equal to 42 degree. With critical angle equal to 40. critical angle 42 degree. In case we have to complete here, it is C equal to 42 degree. How you are getting C? C is equal to sine inverse of refractive index of the error medium divided by refractive index of the denser medium. കേട്ടല്ലേ? ഇവിടെ rarer means air ആണ്, denser medium means ഈ glass material is a glass.
60 degree.
What 60 degree?
Coming out after the 60 degrees. Like this.
ഓരോ സ്റ്റെപ്പിലും തിങ്ക് ചെയ്യുക. ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് ഗ്രേറ്റർ ദാൻ ക്രിട്ടിക്കൽ ആംഗിൾ, യെസ്, റിഫ്ലക്ഷൻ ഈക്വൽ ടു ക്രിട്ടിക്കൽ ആംഗിൾ, ലെസ് ദാൻ ക്രിട്ടിക്കൽ ആംഗിൾ, റിഫ്രാക്ഷൻ. ദാറ്റ്സ് ഓൾ. ഓൺലി 3 things will be there. That is nothing complex. Straight for ഓരോ സർഫസിൽ ഹിറ്റ് ചെയ്യുമ്പോഴും ചെക്ക് ചെയ്യുക. It's coming like this, huh? Okay. உங்களோட பேர் ஸ்டெரிக்கா ஸ்டீவாக்கா? நீங்க?
நான் ஸ்டீவா கார்னஸ்.
ஸ்டெரிக். ஓகே.
இன்சிடென்ட் ரேங்கிறது நார்மல் டு அந்த ரேக்கு எடுக்கிறது தான் இன்சிடென்ட் ரேவா சார்? இல்லை
நார்மலுக்கு நார்மல் அதான் ஆங்கிள் ஆஃப் இன்சிடென்ஸ்.
இங்கே சார் இப்போ நார்மல் 30 refracting angle 30 degree equal to critical angle.
Critical angle 42.
டென்சர் வந்து ரேராக போகும்போது தான் கிரிட்டிக்கல் ஆங்கிள் நோட்ன்ற கான்செப்ட் வருது. இப்போ ரேர் வந்து டென்சர் வருது
வராது.
இப்போ இதேமாரி நான் ஆங்கிளை மாற்றிட்டே வச்சேன், ஐக்கு ஆங்கிளை மாற்றிட்டே வச்சேன். இப்போ ஆடு வந்து டுவர்ட்ஸ் நார்மல் போயிட்டே இருக்கு.
Away from the normal. Denser to rarer.
ரேர் டு டென்சர்.
Rarer to denser opposite.
டுவர்ட்ஸ் த நார்மல் போயிடும். ஒரு ஆங்கிள் வரும்போது நார்மல் ஸ்ட்ரைட்டாக நார்மலே போகும்.
ഒരേ ആംഗിൾ വരുമ്പോൾ നോർമലിലാണ് പോകും. അപ്പോൾ ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് ഈക്വൽ ടു ആംഗിൾ ഓഫ് ആംഗിൾ ഇൻസിഡന്റ് ആംഗിളും റിഫ്രാക്റ്റിംഗ് ആംഗിൾ ഈക്വൽ ആവും. നോർമൽ കൂടെ പാസ് இந்த மாதிரி கேஸ்.
refractive index of the glass.
எதுக்கு ரிஃப்ராக்டிவ் இண்டெக்ஸ் ஆஃப் தி கிளாஸ் எதுக்கு தேவை இருக்குங்களா? ஓகே, ஐ வில் கிவ் n equal to 3/2. தெரியாது, n equal to 3/2 glass material. If you want something, n is equal to 3/2. This is for glass medium. Maybe this is required here. N is equal to how the ray will go? Angle of incidence how much? 0. Angle of incidence 0. Angle of refraction also. So ray will entering. This is 30. This is 90. So this angle is 60. But I want an angle with the normal. That is called angle of incidence. So this angle of and critical angle, ray will undergo refraction. Now this is a normal ray, but I know ray is moving from denser to rarer medium, so it is moving towards the normal or away from the normal. This is the correct path supposed to go. Okay, but because angle of incidence is less than critical angle, ray will undergo refraction and it is bending towards the normal or away from the normal. Away from the normal. So away from the normal. Okay, here away from the normal means there is an angle of refraction is there. This angle also you have to mark. How to mark this angle? Because refraction Snell's law. -90 minus.
Refractive index by using the critical angle.
Sin c is equal to 1/n. Refractive index angle 42 degree. So sin 42.
1 by sin.
தெரியாது.
I think it is sin 45 1 by root. It will be somewhere like that.
1 by root 2 ன்னு சொல்லும்போது 1 by root 2 ன்னு சொல்லும்போது தெரியாது.
Point 7. Sin 45 is 1 by root.
അപ്പോൾ 1.44. അപ്പോൾ അത് ഓൾമോസ്റ്റ് ഈക്വൽ അല്ലേ പ്രിസത്തിൻ്റെ ആംഗിൾ 1.5. ഇല്ല ഇപ്പോൾ സൈൻ സീന്ന് ചൊല്ലുമ്പോൾ sin 42 ഡിഗ്രി, sin 45 എടുத்துருங்க கொஞ்சம் அதிகம். ஓகே இப்போ sin 45 1 divided by 1 by root 2. root 2 மேலே போயிடும். root 2 மேலே போகும்போது 1.4. refractive index of prism equal to 1.414. கொஞ்சம் அதிகம் தான் இருக்குங்களா? அப்போ 1. ലാസ്റ്റിൻ്റെ റിഫ്രാക്റ്റീവ് ഇൻഡെക്സ് കറക്റ്റ് തന്നെ അപ്രോക്സിമേറ്റ്. So done. Right, next heading, circle of illumination. Next heading. Right, the next heading, circle of illumination. Circle of illumination. Circle of illumination. This is simple principle. Normally you have seen we'll be placing some light or something like in a swimming pool areas and all, right? For colorful lights we have normally seen within a water body, for example. Then what will happen? Inside water is not there, right? It's a big swimming pool. I placed one light somewhere under the water. Then I can see the light on the surface of the water only for certain area, not everywhere. So what will happen? So here this is the normal ray. Okay, so many light rays are passing everywhere like this. Many light rays are passing. All set it is passing. So here this is angle of incidence. This is angle of incidence. This is angle of incidence, but different values. Similarly, left side angle of incidence, angle of incidence, angle of incidence like this. Here angle of incidence is very small. Okay, so for this water medium, and ray is moving from where? Denser medium, which means water to air medium. So you have a critical angle. Okay, whenever your angle of incidence is less than critical angle, then what will happen? Ray will undergo refraction. This ray will undergo refractions. This ray will undergo refraction. Suppose this ray is undergo reflection. This ray will undergo reflection. But after some time, you are keep on increasing the angle of incidence. When angle of incidence equal to critical angle, what will happen? Grazing here, grazing here. Up to this you can see the light. After, if you are again giving one more angle of incidence for a bigger value, angle of incidence greater than critical angle, what will happen? This ray will come back to water. The ray is come back to water. Okay, so up to what range you can see the lights? Whenever the first reflection occur. So refraction means this light is transmitting to air. Correct? The light is transmitting to air means you can see that. If light is inside the water only means you can't see that one. So this is the area at which you can see light. Correct? This is the area at which you can see the light. This is like a circular area. It's like a circular area. This angle is the angle up to grazing, you can see. Then after reflections will happen, right? This is a grazing border. So you can see this area, you can light. After that, this is exactly the critical angle. After critical angle, what will happen? Now this is the critical angle, for example. After critical angle, the next line come immediately to reflect. Okay, this is the critical. So the next line will come immediately, it will reflect like this. So for any other, all other higher value, it will undergo reflection. But here only you can see the light. Now this is the border. So at the border line, angle of incidence equal to critical angle. So I am separately drawing center to critical angle. Okay, and the depth of water is to the left. And this is the okay. But what is the angle of incidence will be here? That angle of incidence is equal to critical angle. If this is I is equal to C, means this angle is also equal to C. Both are equal. Okay. Next, find out how much area light is spreaded. So we'll apply Snell's law will be here. Snell's law. So we'll apply Snell's law. N1 sin I equal to N2 sin of R. What is N1? The water medium. So N water. Okay. In sin of angle of incidence, critical angle equal. N2 into N2 is what? Error medium. Air. So refractive index 1. 90. So sin C equal to 1 by N. Okay. C means what? Opposite side by hypotenuse. So opposite side means what? 1 by hypotenuse. So what is this side will come? Root of n square minus 1. Root of hypotenuse square minus base square on e side. Okay. Next, from this one, what is tan C? Tan C means what? Opposite side by adjacent side. So 1 divided by root of n square minus 1. Why I am taking tan C means because I required here to find out the radius. What is tan C of this triangle? Tan C means what? Opposite side by adjacent side, R by D. What is tan C we got on that side? 1 divided by root of n square minus 1 equal to R by D. So radius is equal to how? Root of this you have to. Question is which area the light is spread. So they are asking d square divided by n square minus 1. This is the question, but you have to remember this formula. Okay. Circle of illumination. So below right, when a light is placed on a water body, when a light is placed on a water body, when a light is placed on a water body, the light is spreaded over the surface of water. Over the surface of water till the angle of incident is equal to critical angle. Till the angle of incident is equal to critical angle. Incident is equal to the above critical angle. Above critical angle, the ray will get reflected back. Above critical angle, the ray will get reflected back. Critical angle. Just angle of incidence has to mark. After some time, angle of incidence is equal to critical angle. Later sometime, angle of incidence angle of incidence. While you are drawing the diagram, you have to make sure that the border of the circle at which the ray is grazing, till that refraction. At the border it is grazing. At the border what will happen? Reflection will happen. Circle the border refraction is happening with r equal to 90 degree. After the border, what will happen? Reflection is happening. Then you can complete the things in the border. Within the diagram draw ya, then Snell's law apply ya, formula tan c vechu apply ya, then area pi r square pi into d square by n square minus. Please remember this formula. Okay, d by root of n square minus 1. Always remember the formula, so it is easy to quickly answer it. So the area pi d square by n square minus 1. Sometimes they will ask you the length. Length means 2 times of radius, diameter. Total length area. Instead of asking area, they will ask you the total length. Total length means 2r diameter. Okay, depends on the question. Length is total area. Length so 2r. Area is pi r square. Depends on the question. Okay, then write one question. A point source of a question. A point source of below a glass slab. A glass slab of refractive index 5/3. Refractive 5/3. The thickness of the glass slab is 8 centimeter. The thickness of the glass slab is 8 centimeter. Find the area through which light emerges. Find the through which light emerges. then based on, it's a glass slab, so like this, and light, and its length is 8 centimeter. It's refractive, so of course the light will be emerges and some area will be here, and you have to find out this area. But you know this height and these things, you know. This is called critical angle. Ray is grazing, and this is called angle of incidence. So radius has to find out first. Radius square minus 1. D depth. Depth is how much? 8 divided by 25 by 9 minus 1. Root uണ്ടല്ലേ? Root 25 minus 16 by 9 the root 4 by 3. 4 by 3. So 24 divided by 4, correct? 6. So radius is 6. Okay. A how much? Area is equal to pi r square. So pi into 36. 36 pi centimeter square. In terms of glass slab, they may ask with water also. Okay, depends on, but method will be the same. If you know this formula, this is a pulse. This is actually the crux of the topic. You will get the answer to the questions clearly. That is the intentions over here. Okay, then understood, right? Then below, right? Mirage. GL. MIRAGE. Mirage. Optical illumination, correct alla? Normally highways la pogumbodhu, road la pogumbodhu, will feel like a water will be there. That is because of the total internal reflection, because of the reflections. Okay, so mirage is an below, right? Mirage is an optical illumination. Mirage is an optical illumination. Mirage is an optical illumination normally observed in road, deserts. Just to understand, so total internal reflection or application on a mirage phenomena what we have seen. Next one is optical fiber. Optical fiber.
അതിനകത്ത് ബ്രേക്ക് എടുത്താൽ ചെറിയ പ്രശ്നമുണ്ട്, പാരാകുന്നില്ല, അത് ഓഫ് ആയിട്ടാണ്.
ഇപ്പോൾ പേരല്ല നോക്കണം, ഓക്കെ പോസ്റ്റ് ചെയ്യണം 5 minutes. So next one, optical. Normally audio video signals normally internet signals transmit and use optical fiber. Optical fiber ന്റെ ഉള്ളിൽ പോണതന്നെ total core cladding. So ഇപ്പോൾ critical angle. Okay, ഇതിന് core cladding ഈ കോറിന്റെ refractive index higher ആയിരിക്കും, cladding refractive index lesser ആയിരിക്കും. അപ്പോൾ ray is moving from denser medium to rarer medium. ആ ഒരു സിറ്റുവേഷൻ ആക്കി ക്രിയേറ്റ് ചെയ്യും. So ray will be passing like a wave. Okay. So optical fiber, it's an application of total internal reflection is an application of total internal reflection, normally used for audio, video, signal transmission. Audio, video, signal transmission. You are sending videos over WhatsApp, you are sending photos over WhatsApp, right? How it is reaching on others end? There is no connection, right? How it is going? Where it is going? Radio waves alla illa, how it is converted into wave? Adinte background, you are sending photos, you are sending voice messages, you are sending blah blah. Where it is going or how it is transmitting? How it is transmitting ketna adukku frequency irukum. Okay, every signal will have a frequency. Our frequency, if I am sending some messages to somebody, so the messages should definitely, it is throwing to air only finally. Okay, but the messages should catch the right recipient. Okay, correct ആയിട്ട് ആ റിസീവ് ചെയ്യുന്ന the person who is receiving should be the correct person whatever you are sending. How it is reaching on the correct person? Suppose Shabri is sending some messages, it will be, he is supposed to send me, but the message will be reaches on each one of your phone, but your phone cannot recognize it. What is happening? There is something called cryptography. Okay, cryptography, which is something called an algorithm in the sense some stuff will be there. Okay, so your phone can able to decode this. Every phone is trying to decode the information, sir. Okay, so that information is a 8-bit information, like 1010 pattern, 8-bit information will be there. So this 8-bit information will be the head of the message. That's a message you are writing. If I can 1 KB illana 5 MB video sorry 5 MB 5 megabits ആണ്. Okay, 5 megabits എന്ന് പറയുമ്പോൾ 10 power 6 அந்த அளவுக்குള്ള ബിറ്റ്സ് ഉണ്ടാവും. അതിൻ്റെ ഫസ്റ്റ് 8 ബിറ്റ് എന്ന് പറയുന്നത് ഫസ്റ്റ് ഇരിക്കുന്നത് അതിൻ്റെ ഹെഡർ, അതൊരു ക്രിപ്റ്റോഗ്രാഫിക്, അതൊരു എൻകോഡഡ് സ്റ്റഫാണ്. നോബഡി കനോട്ട് റീഡ് ഇറ്റ്. அதை கரெக்ட் ரெசிபியன்ட் மட்டும்தான் അതിൻ്റെ ഇൻഫർമേഷൻസ് ഡീകോഡ് பண்ண முடியும். So if somebody is sending some message means everybody in the world is receiving it, but only one member can unlock it. അതാണ് ആ കീ ഇരിക്കും, ഒരാളുടെ കയ്യിൽ மட்டும்தான் കീ ഇരിക്കും. He will go and open it. Nobody cannot open it. അതാണ് ഈ എൻകോഡിങ് ഡീകോഡിങ് എന്നെല്ലാം പഠിക്കുന്നില്ല, അതാണ് എൻകോഡിങ് ഡീകോഡിങ്. അപ്പോൾ every message is going through a single optical fiber. Okay, you are sending messages, I am also sending messages, everybody. Geo fiber എന്ന് சொல்லிட்டு normally ഇപ്പോൾ ജിയോ ഫൈബർ, എയർടെൽ ഫൈബർ, ഇതേമാതിരി ഓരോ ഫൈബർ നെറ്റ്വർക്ക്സ് everybody is going through single channel. അപ്പോൾ മിക്സ് ആവുന്നില്ല, ഇറ്റ് ഈസ് നോട്ട് മിക്സിങ്, കാരണം അതിൻ്റെ പാറ്റേൺ എല്ലാം ഡിഫറെൻ്റ് ആണ്. ബാർകോഡിങ് മാറിയതാണ്. ബാർകോഡിങ് പറഞ്ഞാൽ എല്ലാം ഒരു സ്ക്വയർ ആയിരിക്കും, ഏതോ கொஞ்சம் ഡോട്ട് അതേമാതിരി தான். ബട്ട് എവറി ബാർകോഡ് ഈസ് യുണീക്ക് കേട്ടോ. അതേമാതിരി தான் we can create n number of enormous different permutations and combinations. അതാണ് ഒപ്റ്റിക്കൽ ഫൈബറിൽ പോകുന്നത്. Every audio signal or every video signal is transmitting through a single channel, but I am giving you an encoding informations and somebody can only decode it, not everybody. അതുകൊണ്ടാണ് അത് കറക്റ്റ് റെസിപ്പിന് എത്തുന്നത്. Sometimes you may experience while attending the call or while speaking over a phone, you may hear your voice written. Sometimes you may hear your voice written. Sometimes you may rarely, since others' noises are interfering. Others' noises, you may cut the call, then again you try, or you will get a reflection of your voice back. Okay, reflection of your voice, you are getting the reflection of your voice because of two reasons. One is the phone reason. Okay, okay, it depends upon the quality of the phone. Second one, signal interference. അപ്പോൾ അതിന് ജനറലി ചൊല്ലും സിഗ്നൽ ഇൻ്റർഫിയറൻസ് ഇല്ല, നമ്മൾ ടവർ ഇല്ല, അതേമാതിരി ഇല്ല, നമ്മൾ ജനറിക് ടേംസ് യൂസ് ചെയ്യണം. But in terms generally signal interference voice signals in high frequency അതുകൊണ്ടാണ് അത് interference കാരണം noise ആയിട്ട് interfere noise is a high frequency signal voice is also a high frequency so interference chances higher ആണ് but you see like how many crores of people are talking in a moment but it is not interfere, right? Every time the signals are transmitting over phone call, how many people in 1 second, how many are checking the phones? Okay, how many are talking over a phone? That is the thing. Recently Samsung will introduce some survey reports state that on an average Sunday everybody is a normal holiday time, right? On an average a man will unlock his phone minimum 30 times per day. That's average. Maybe you are less, you are a greater. 30 times per day you are drawing the pattern. They have done some measurement. 30 times a pattern drop maybe you are taking maybe less than 1 second. Okay, or 1 second. How many users will be there? That users into multiplied with that many number of phone multiplied with that many number of seconds, it will be given as in terms of years. Okay, in terms of years a second in people are number of 2010 survey 5 times 2020 survey result, which means at the time if you are unlocking 5 times, now you are unlocking 35 times now. 10 times faster, more than 8 times, 7 times higher comparable to the last 10 years. That's the story. Because users will be more, technology fast, optical fiber, fiber technology, fiber a lot of combinations. 4G 5G. 5G, what is the difference between 4G and 5G? Only thing I know, it will be very, very fast. But how it is become fast? Okay, why US and 5G, Europe and 5G, but we have still no have 5G. 5G maybe the next 5 to 10 years. Okay, but why 5G is not there? 5G and then the advantage many Gulf countries will have 5G systems. Many phones are supporting 5G, but we don't have 5G. 5G 5G 4G difference optical fiber difference. Google it and find. Write the next topic. Prism. In optics, prism, what is the shape of prism? Hey, tell me what is the shape of not correct. Prism is a triangle. Prism can be any shape. Okay, so far we have learned like this only. That's what you tell that it is triangle. Triangle is any shape. If it is a cube also we can call it as prism. If it is a rectangular box also we can call it as prism. Anything we can call it as prism in generally. But we will normally learn this triangular structure called a prism. Okay, so we'll analyze if an incident ray is coming to the prism, what will happen? This is going from which medium to which medium? Rarer medium to denser medium. So I have to draw a normal here. So what will happen? This is not going like this, it will bending towards the normal like this. Then I will draw the next normal line to this one, this prism, next normal line. So this now is going from denser medium to rarer medium. This is supposed to go like this, but it is moving away from the normal. So it is not moving towards the normal, it is moving away from the normal. Correct. So this is the straight way suppose the incident ray should go. But because of the prism, the ray is now, what will happen? Deviated this much. And this delta is called angle of deviation. First term on angle of deviation. Okay, first term, angle of deviation. And this is called angle of incidence I. And this is called angle of refraction R1. And for the second surface, this is R1, right? And with respect to the normal, and this is not this one, this is the normal, right? R1, normal angle is R1. And for the second surface, this angle is the angle of incidence, and it is given as R2. Kana inside R1 R2 varudhu. This is actually an incident angle. Then the ray is going out, and this angle is the angle of refraction, and this is called it as E, angle of emergence. Okay, எல்லாமே சேம் ആണ്. இதான angle of incidence, angle of refraction, angle of incidence, angle of refraction. But prismathil varumbodhu we call it as angle of incidence and angle of refraction. Angle of refraction, it's not actually angle of refraction, angle of incidence only, but it is written as R2. And this is angle of refraction, and it is written as angle of emergence. So I, angle of incidence, and R, angle of refractions. R in the sense two things, R1 and R2. Then what else will be there? E, angle of emergence. Okay, what is called the deviation? What is this angle? What is this angle will come? This total angle is called this total angle of incident, and this total angle is how much? I. Correct? This total angle is I. So what is this angle will come? This alone, I minus R1. Okay, similarly, what is this angle is come? This double line angle is how much? Total it is E, R2 is subtracted, so this angle is comes as E minus R2. Okay, so what is delta? Delta is an exterior angle. Maxwell principle, exterior angle is equal to sum of interior angles. So based on that, delta is called an exterior angle. ഒരു triangle exterior angle ആണ്. Exterior angle is equal to sum of interior angles. So how many interior angles? Two interior angles. So delta is equal to I minus R1 plus the next interior angle is what? E minus R2. This together can be written as I plus E minus of R1 plus R2. This is called deviation. First point called deviation. Second one, the prism will have this angle. This angle of prism is called A. So the next point is called angle of prism. Angle of prism is nothing. The angle of A is called prism angle, angle of prism. This is also called apex angle. Apex angle is also called A. Apex angle, angle of prism. Both are same, all are same. Prism angle A. Okay, now we'll consider a triangle over here. For example, small triangle in the sense like this. Not a triangle, a rectangle. This is called A. Correct. This total value is called A. Here it is meeting, and here some rays are going like this one. For example, prisma's side ray is moving, and this angle is how much? This is a normal ray R1. Okay, and this angle is how much? I minus R1. And what about this angle is coming? Total angle is how much it is coming? From the diagram, this is coming as R2, so I can return total angle is 180. So 180 minus of R1 plus R2. I want this angle also. What is this angle? 90. Anyway, these two are perpendicular, right? These two are perpendicular. So this is 90 minus R1. This is 90 minus R2. Correct? Because this is the normal ray which is coming from there, and this is the side of the prism like this, and this is the next normal ray like this. Now I am extending the figure. So this is R1, 90 minus R1, R2, 90 minus R2. So all together A plus this total angle is 90 plus this angle is 180 minus R1 minus R2 plus this total angle is 90. Okay, so is equal to how much degree will come? Total is how much? 360. Okay, total is 360. So A plus 90 plus 90, 180, 180 plus 180, 360. A plus 360 plus not plus, minus r1 minus r2 is equal to 360. This goes out. Correct? So A is equal to r1 plus r2. So which means angle of prism is equal to the first refracting angle plus second incident angle. Okay, the A is equal to r1 plus r2. Understood? These all the terms we have to write, and yeah, we will write this first, then we'll move to the minimum deviation topic. Okay, so we will write this first. So prism, first you have to draw the diagram. Please draw a bigger diagram, half the size of your notebook. Matchbox mari podakodadu, big diagram, because many things will be there. I and r1 and e and r2 and many stuffs will be there. adonna solladhu matchbox mari potina theriyadu. In the board ivlo perusu pottradhu, this much complexities are there. And notebook in a half the size kuda every angle clear aayirikkanam, multiple colors irundana adu use pannina better irukum. Then mark everything in very clearly. Every parameters should be clear. Complete the diagram. Then it's on thane on current vanda sa current came I don't know verla adana AC off adala, AC off adana, current is not there. Current is not sollu correct tappu da, voltage is not there, so நம்ம கரண்ட் கட்டனதால சொன்னேன். அது கரெக்ட் இல்ல, அது நம்ம ஜெனரல் அப்படியே அதே மாதிரி நிறைய சொல்லுங்க பேட்டரி ஃபோன் சார்ஜ் தான், ஃபோன் பேட்டரி கரெக்டாக. Good habit and bad habit and everybody. Bad and சொல்ல முடியாது, அது என்ன சொல்லுவீங்க, transferring from one generation to next generation, it's going. Only draw the diagram, don't write anything. We will write in an ordered way. Okay. If you're already written, it's okay, I'm telling. Otherwise, don't write. We'll write in ordered way. Angle of prism, delta, deviations, then we have still something will be there, something called minimum deviation, etc., etc., etc. Okay, completed the diagram. Okay, now diagram complete edukku 5 நிமிஷம், பிரியாணி கொடுத்தனா 5 நிமிஷம் கரெக்டா? Okay, we'll write then write. You have marked A, right? This has to mark. The angle A is called AC on. The angle A is called the angle A is called angle of prism slash, put a slash or slash angle of prism, apex angle, prism angle. Angle of prism, apex angle, prism angle. Okay, that's all. Then write a small subheading, deviation. Deviation delta. Deviation is a bracket delta. Deviations delta. Okay. Deviation is the angular difference between the deviated ray and incident ray. The deviated ray and incident ray. Next point, delta is an exterior angle. Delta is an exterior angle which is equal to sum of interior angles of the triangle. Delta is an exterior angle which is equal to sum of interior angles of the triangle. Okay, then you have to draw a small diagram like this. This is called delta. This is I minus R1 and this is E minus R2. Portion interior portions we drawn there. I minus R1, E minus R2. Delta. Then write delta is equal to I minus R1 plus E minus R2. Delta equal to I plus E minus R1 plus R2. Okay. Fine. Then up to this. Then next heading, similar to angle of deviation, next heading prism angle. Prism angle, then draw this diagram. For prism angle, draw this diagram. And then write A plus 90 plus 180 minus till A is equal to R1 plus R2. A is equal to R1 plus R2. Prism angle is equal to sum of two internal R1 and R2 angles. Next heading, after writing to A equal to R1 plus R2. That is the caprola. Next heading. Relation between A and delta. Relation between A and delta. We know delta equal to I plus E minus of R1 plus R2. We know A is equal to R1 plus R2. So delta equal to I plus E minus A. Okay, write a question. Find angle of deviation. Find angle of deviation and angle of emergence. Find angle of deviation and angle of emergence. Find find angle of deviation and angle of emergence for an equilateral prism. For an equilateral prism. For an equilateral prism. You will do, right? Yes or no? Angle of emergence first കണ്ടുപിടിക്കണല്ലേ? Emergence 60 ആ, but deviation ആ 260, both are 60. Jayashree answer है 2 में 60 आ ओके निधीश है आंसर ಇಲ್ಲ both 60 okay Backside got the answer, huh? All of you? No. No. Okay. How to do will be here. What is happening will be here. Refractions. Okay. Refraction, because it's a glass prism, so the refraction is happening. Okay. So suppose the ray is entering into the prism. Okay. So this is called angle of refraction. Okay. Angle of refraction. I am applying Snell's law will be here. Okay, first step here Snell's law applying. So what is Snell's law? N1 air into sine of 60 equal to N2 prism into sine of R. This is root 3 by 2 is equal to root 3 sine R. R equal to 30 degree. So now I got R equal to 30 degree. Here also what will happen? Here I got 30 degree. Okay, so this is basically my R1. So R1 equal to 30 degree. I know the prism angle A equal to 60 degree. This is equal to R1 plus R2. Correct? But R1 I already know it is 30. So 30 plus R2. So R2 equal to 30 degree. R2 equal to 30 degree. So I got this incident angle is also 30 degree. Now again I am going to apply Snell's law. I have to find the angle of emergence. Angle of emergence. So what will come? Step number 2. Again applying, here also applying the Snell's law. N1 sine 30. N1 is what? Prism. Root 3 sine 30 equal to N2 is what? Air. So 1 into sine of angle of refraction, sine of emergence. So this become what will come? Root 3 by 2 equal to sine E. So E equal to 60 degree. Emergence equal to 60 degree. So emergence got. Third step, delta equal to I plus E minus prism angle. I is how much? Angle of incidence 60. Emergence is 60. Prism angle is 60. Answer is 60. 60. So all are 60 degrees. Clear? Both are 60 degree is the correct answer. Next question. Find the angle of emergence. Find the angle of emergence. Step 3. Delta plus I plus E minus A. So 120 minus 60, which is equal to 60. Find the angle of emergence. value of E? Hello? What's coming? What's answer you got? 45. 45. Okay. Backside all eppudu mere 45. But answer front 90. We'll see. Angle of incidence 45 degree. Angle of refraction has to find out. Step number 1, applying the Snell's law. 1 into sine 45 equal to n into sine of r1. Sine 45 1 by root 2, 1 by 2, r1 30 degree. R1 30 degree. Step number 2, A equal to R1 plus R2. A is 75, R1 is 30, so R2 is R2. So R2 equal to 75 minus 30, 45. Again applying the Snell's law for the third phase. So what I understood from here is, the ray is coming like this one, angle of refraction 45. If this is 45 means this is also 45. Which one? R1 is 30 degree. R1. This is 30 degree. So definitely this become 60 degree. Okay. Then the ray is coming here, interfering here. Then R2 means degree. This angle is 45 degree. Next I want emergence. So the ray is going. Emergence has to slow again apply. Snell's law. 1 here root 2 into sine is equal to 1 into sine of E. Root 2 into sine 45 1 by root 2 sine E. E is equal to 90 degree. Eppadi 45 anna? 45 alla. என்ன ஆங்கிள் கிரிட்டிக்கல்? எப்படி கிரிட்டிக்கல் ஆங்கிள் வரும்? ஒரு செகண்ட் சொல்லுங்க. അപ്പം കറക്റ്റാണ്. അതായത് എമർജൻസ് 90 എന്ന് ചൊല്ലുമ്പോൾ ഇത് കൂടെ അങ്ങനെ പോകും. അവനെ ഗ്രേസിംഗ് ഓവർ ദ പ്രിസം കറക്റ്റല്ലേ? ഫസ്റ്റോ നോ, ഹിയർ ഇറ്റ് ഇസ് മൂവിംഗ് ഫ്രം rarer to denser. When it will graze, denser to rarer. This is moving from rarer to denser. Here only it will graze, denser to rarer. Here you got her doubt, huh? She is asking, sir, here critical angle means what? Sin C. Sin C Mamad, refractive index of the divided by refractive index of the denser medium. So sin C is equal to rarer medium is 1, refractive denser medium is root 2. So 1 by root 2, which means critical angle is equal to 45 degree. If critical angle is equal to 45 degree means here angle of incidence is equal to critical angle. The ray is no. That is a doubt. No. Why? Because to happen the angle condition, it has to move from where to where? Denser to rarer. Here it is moving from rarer to denser. That's why it's not grazing here. But it is grazing because it's moved denser to rarer. Clear up? No problem. Well, this might happen. Like a part of next question. The answer is not. There any sure short answer. Find the angle of emergence. 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 Refractingness root 3. N equal to root 3. Hostel ஏதோ மிஸ்டேக் இருந்தால் அப்போ கண்டுபிடிச்சிடும். கரெக்டாக இல்லை, ஏதோ மிஸ் ஆகினா டக்கு சொல்லும். ஓகே, நோ ப்ராப்ளம். தட் இஸ் எக்ஸ்பெக்ட் ரைட். வித்தவுட் தட் ஐ கேனாட் ஆன்சர். கரெக்ட் ஒன்லி. நம்ம இங்கே ட்ரா பண்ணும்போது சம்திங் வில் மிஸ்ட். சொல்லுங்க ஏவா கரெக்டாக ஆன்சர் சொல்லுங்க. ப்ரெஸ் ஆங்கிள் 90 120. ஓகே. ஜீரோன்னு சொன்னால் பர்பெண்டிகுலர் டக்கு போயிடணும். ഓക്കെ ഇതേ മാതിരിയാ. അപ്പോൾ എൻ്റെ നോർമൽ എങ്ങനെ ഇതാണ് നോർമൽ. நீங்கள் சொல்ல ஜீரோன்னு சொல்லினா இப்படி போகக்கூடாது, இப்படி போனீங்களா? எப்படி போகும்? 290. அப்போ 290 இப்படி போய் இங்கே சுற்றி வரீங்களா? கொஞ்சம் யூஸ் பண்ணுங்க, இப்போ வரும். இப்போ சொல்லுங்க சபடி. சரி, ஆப்ஷன் A 0, ஆப்ஷன் B sin inverse of root 3. அடுத்தது அடுத்து that's all. 90. Coming. Then next, one more option, come on. Preeta can contribute one more, Preeta. இதுக்கு எவ்வளோ ஆன்சர் வேணும்னு சொல்லலாம், பட் கரெக்ட் ஆன்சர் சொல்லுங்க, சாக்லேட் வாங்கி தரேன். எவ்வளோ ஆன்சர்னு சொல்லலாம். இப்போ ஆல்ரெடி 4 ஆப்ஷன்ஸ் இருக்கு, அதில் ஏதோ ஒரு ஆப்ஷன் ஸ்டிக் செய்யாம். பட் யூ ஹேவ் டு டெல் த ஆப்ஷன்ஸ் லவுட்லி, தென் only I can write there. Okay, option A Author Sabari, option B Balasubramanian, option C Aishwarya, then option D 90. 90 का पे 2 பேர். Sin inverse of root 3.
This prism cannot exist.
This prism cannot exist. So none of the above. This will come, right? Anyway, that will be the option. Okay. Prism not exist. Prism is exist. Prism is exist. Why? Because 120 plus 90 plus 30, 180. Prism will definitely exist. 180 degree. Prism will exist. You can say question is not exist. Appo correct irukla. Original Neet la irundhalum they will delete 2 to 3 questions. അല്ല ഒറിജിനൽ നീറ്റ് എക്സാമിലും they will delete 2 to 3 questions wrong ആർക്ക് എപ്പടി ഇരുന്നാലും.
Refracting angle 30 degrees, sir. Then adjacent to case, this will become 60 degrees, sir. Then this two angle will totally, if we add up, it will get 180 degrees, sir. Then this will be 0 degrees, sir. Then this cannot be a triangle anymore.
So what to do?
So like this question we cannot.
Back side answer சொல்லுங்க. ആഹാ ഏത് സ്കൂളിൽ പഠിച്ച്? എന്നാ സ്കൂള്? SBO야? நீங்க அதே ஸ்கூலா? அமிர்தா. நெக்ஸ்ட் ஸ்கூல் சொல்லுங்க. எல்லா ஸ்கூல் கோயம்புத்தூர் சைன் ஆஃப் இன்வெர்ஸ் ரூட் 3. സൈനിന്റെ മാക്സിമം വാല്യൂ എவ்வளோ? സൈനിന്റെ മാക്സിമം വാല്യൂ എவ்வளோ? 1. സൈൻ ഇൻവേഴ്സ് 1 എவ்வளோ? 90. അപ്പോൾ സൈൻ ഇൻവേഴ്സ് റൂട്ട് 3 എவ்வளோ? സൈൻ ഇൻവേഴ്സ് റൂട്ട് 3 എന്ന് പറഞ്ഞാൽ സൈൻ ഇൻവേഴ്സ് ഓഫ് 1.7 വാല്യൂ എക്സിസ്റ്റാ? തന്നെ സ്കൂൾ ഏതാ കേട്ടെ? ഇല്ല, ഇപ്പോൾ റൂട്ട് 3 വരാതെ ദിസ് ഈസ് ആൻ ഇമ്പോസിബിൾ ആൻസർ. സൈനിന്റെ മാക്സിമം വാല്യൂ 1 അല്ലേ? കറക്റ്റ് അല്ലേ? ഐ ക്യാൻ റൈറ്റ് തീറ്റ ഈക്വൽ ടു സൈൻ ഇൻവേഴ്സ് ഓഫ് 0.5. യു ക്യാൻ സേ 30 ഡിഗ്രി. I can write sine inverse of 1, you can say 90 degree. But if I am writing sine inverse of 1.7 പോടാൻ ചൊല്ലു. കേട്ടല്ലേ? It's not possible. Sine maximum value എவ்வளോ? 90. 90ക്ക് മേലെ വന്നാൽ പിന്നെ റിട്ടേൺ ആവും, നെഗറ്റീവ് വരും. 0 to 1 ആണ് റേഞ്ച്. കേട്ടല്ലേ? So what's the answer for the question? Sorry. 90. Okay. അപ്പോൾ ഫൈനലി എല്ലാം ഫിൽറ്റർ ചെയ്തു. നെക്സ്റ്റ് വിൽ സി വാട്ട് ഈസ് ദ ട്വിസ്റ്റ് ഇൻ ദ ക്വസ്റ്റ്യൻ. ആരുമില്ല, നോബഡി. ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് 60 ഡിഗ്രി. Angle of refraction. So angle of refraction in this one R1. What should I will apply? Snell's law. N1 sin I equal to, N1 is air medium, of course you have taken that. So 1 into sine of 60 is equal to root 3 into sine of R1. Sine 60 is root 3 by 2 is equal to root 3 sine of R1. So R1 is equal to 30 degree. Up to this you got about 20% correct. Okay. Then immediately we are drawn the line like this. Then story will just. Kata. This is 30. What is this angle? 60. Then what is angle? 0. Ayyo. 0. This is possible, huh? This is possible, huh? This is possible. எப்படி 0 வரும்? வராது. No chance at all. Okay, no. This angle 0 will not come. This means the ray is not going here. The ray will go here. Okay, the ray will go here. റേയുടെ പാത്ത് ചേഞ്ച്. ഇതുവരേക്കും പഠിച്ച മെത്തേഡ് അല്ലല്ലോ, ഡിഫറൻസ് ഇല്ലേ ആ ഒരു റേ വരുന്നത്. ഇത് ആഫ്റ്റർ റിഫ്ലക്ഷൻസ് ദ റേ വിൽ ഗോ ഹിയർ, which means we'll see. കാരണം ഈ 60 വെച്ചാ so this is will be here. Okay, so what is the meaning of this one? Angle of this is the angle of refraction is 30 degree and this angle is 30 degree. This angle will be here. Again, this angle, what is this? Again will be here. And this is also 30 degree and this angle is 60 degree. Now I have to see what is up. I will pencil over here. Is coming 1 into root 3 into sine 60. Okay, root 3 into sine 60 is equal to, what is coming? Suppose it is going refractions. So what has happened? Root 3 into sine 60 is equal to 1 into sine of out angle. Out angle is emergence. I consider like an emergence. But again I got root 3 into sine 60 means what? Root 3 by 2. So which means 3 by 2. 1.5 sine E, not possible. So what is happening? Not possible means this I applied, what is applied will be here. Snell's law I applied. Snell's law I applied. And this is saying Snell's law is not possible. Snell's law is not possible means refraction is not possible. So what will happen? Reflection will happen. Ray will get reflected. Ray will be getting reflected. What is the angle of reflections now? 60 degree. If this is 60, what is this angle? 30 degree. This 30, 30. How much it is? 60. So what is this angle will come? What is this angle will come? 120. But we'll keep it like this. Now the ray will be getting refracted. Okay. The ray will be getting ray will be getting reflected. I don't know what is going to happen there. Now angle of incidence and angle of reflections. So what we have to do will be here. We have to draw a normal to the surface and we have to calculate this angle. Up to this it is clear, yeah? So it will not come here because 0 degree is an impossible value, so ray is getting diverted. I again assumed okay, refraction may happen. I applied Snell's law, then again I come to the conclusion no, this is not possible. Sine E 1.5 not possible because E is maximum is how much degree will come? 1, maximum 1 will come, but 1.5. So this is not possible. Refraction is not possible. So what is the other option? Reflection. So the ray reflected back. Now the ray is getting reflected back. I want to calculate the angle of incidence. What is the angle of incidence in this case? This is the triangle is much congested. This is 30 degree. I want to calculate this angle. Angle of incidence is how much? Yeah? How 30? The angle 30. This angle is 30 degree. Correct. Now again I am assuming maybe refraction is happening. I am applying the Snell's law. Snell's law is what? Root 3 into, correct, root 3 into sine of angle of incidence. Sine 30 is equal to 1 into sine of angle of emergence. Now I got root 3 by 1 by 2 is equal to sine E, which means 1.7 by 2. This is possible. 1.7 by 2 means 0.8 is equal to sine E. 1.7 by 2 means 0.886 value. So E, so which means E equal to 60 degree. Answer is 60 degree. What happened? So what is the problem is like whatever you have learned, the ray is not always like this. It may go like this also. That's the question. കാരണം ഇതുവരെയൊക്കെ പ്രശ്നത്തിൽ കണ്ട ഡയഗ്രം എങ്ങനെ വരുന്നു, ടക്കിന് പോകുന്നു, ടക്കിന് വരുന്നു. അതിന് ഡിഫറെൻ്റ് ആയി. റിഫ്രാക്ഷൻ, റിഫ്ലക്ഷൻ, റിഫ്രാക്ഷൻ. അതാണ് ക്വസ്റ്റ്യൻ്റെ ട്രിക്കിനെസ്.
How that angle of incidence is 30 degrees?
This is 60. This is 30. Now if you draw one line like this, if you draw one line like this, or one horizontal line, if you draw, okay, can you draw the same diagram? I mean, not with the value in a bigger size. I'll explain that. If I put it will be here, you'll be getting confused. One second, I'll go. கொஞ்சம் bigger size போடுங்க. Simple ആയിട്ട്. Okay, one more method. ഇത് 30, ഇത് 30, എவ்வளോ? 60. അപ്പോൾ ഇതിന്റെ ടോട്ടൽ ആംഗിൾ എவ்வளോ വരണം? 120. ഇത് നോർമൽ ആണ്. അപ്പോൾ നോർമൽ ഇരിക്കുമ്പോൾ ഈ ഒരു ആംഗിൾ എவ்வளോ? 90. അപ്പോൾ ഇത് 30. கொஞ்சம் அண்டர்ஸ்டுடா? இது மாதிரி தான் கொஸ்டின்ஸ் வரும். இது மாதிரி தான் கொஸ்டின்ஸ் வரும் எக்ஸாம். ஜெயிக்கல நீட் கேட்கும். Angle of emergence 60 degree. Doubt? Okay. Do not think like ray is always going to next phase. It should not be like that always. Out of box thinking. படிக்கிற மெத்தட் கொஞ்சம் வெளியே விட்டு திங்க் பண்ணணும். அப்ப இது மாதிரியும் வராம். രണ്ട് ഫിനോമിന தான். റിഫ്രാക്ഷൻ, റിഫ്രാക്ഷൻ, റിഫ്ലക്ഷൻ. റിഫ്രാക്ഷൻ ഇല്ലെങ്കിൽ റിഫ്ലക്ഷൻ, റിഫ്ലക്ഷൻ ഇല്ലെങ്കിൽ റിഫ്രാക്ഷൻ. Something will happen definitely. So here refraction, reflection, refraction. Now it is 60 degree. So ray will be emerges out with an angle equal to 60 degree. Understood Abhida? Correct dana logic.
சென்டிமீட்டர்ஸ் ஆஃப் 3 சார். நீங்கள் சொன்னீங்க அது டேனாக வந்து அப்ராக்சிமேட்டாக போகலான்னு சொன்னீங்க சார். இது போட்டால் 60 டேரக்டாக இருக்குது சார்.
Sin is approximately equal to tan, correct, for smaller values of theta. Yesterday also I told, right, for small values of theta, not for bigger. 60 is a bigger value. Less than 30 அதே மாதிரி வேறு ரேஞ்ச் 15, 10, 20 அதுக்கெல்லாம் அப்ராக்சிமேட்லி ஈக்குவலாக இருக்க வேல்யூஸ். நீங்கள் கால்குலேட்டர் அடிச்சனால அதே மாதிரி இப்போ tan ஒரு 10 அடிச்சு, sin 10 அடிச்சுன்னா சரி சின்ன டிஃப்ரென்ஸ் தான் இருக்கும்.
ക്രിട്ടിക്കൽ ആംഗിൾ നോക്കുമ്പോൾ 1/√3
മതി 1/√3 എന്ന് പറഞ്ഞാൽ ക്രിട്ടിക്കൽ ആംഗിൾ
റിഫ്രാക്റ്റിംഗ് ആംഗിൾ 90 ഡിഗ്രി ആയിരുന്നു. സെക്കൻഡ് R2
0 അല്ലേ?
R2 90
അല്ല R1 വന്നു, R2 0 അല്ലേ വന്നു? 0 വന്ന് 90 വന്നു. അങ്ങനെയും ആലോചിക്കാം. കറക്റ്റാണ്. അതായത് ക്രിട്ടിക്കൽ ആംഗിൾ കണ്ടുപിടിച്ചു, 1/√3 എന്ന് കണ്ടുപിടിച്ചു, 1 ആവും. അപ്പോൾ അത്രയും വരില്ല, അപ്പോൾ റിഫ്ലക്ഷൻസ് വരും. അങ്ങനെ ചിന്തിക്കാം. അങ്ങനെ ചിന്തിക്കാം. കറക്റ്റാണ്. Finished, huh? Okay, write the next heading. Factors depending on angle of deviation. Heading. Factors. This is finished, else I will wait for you. Okay. Factors depending on angle of deviation. Factors depending on angle of deviation. Number one. First is refractive index of the prism increases. Refractive index of the prism increases. refractive index of the prism increases, delta increases. Delta, factors affecting delta. Number one, when refractive index increases, delta increases. Number two, angle of prism increases, angle of prism increases, delta increases. The correct not correct, right? Delta is equal to I plus E minus E. But E increase and delta decrease. It should not be like that. Delta equal to I plus E minus E. You may thought like, okay, A increase, delta should decrease, right sir? No. If you are increasing angle of prism A, proportionally emergence also will increases. Okay, that's what when A increases, delta is also increases, because the increase of A is give a more increase in E, emergence. Okay, that's what this statement is important. This will ask for examination. Number three, when wavelength of the light increases, deviation decreases. So deviations for violet rays is greater than deviations for red light, right? Web geo. High frequency, low wavelength. So if you are writing V I B G Y O R. Okay. So how I can write the deviation here? Less wavelength, right? Less lambda, and it is increases to more lambda. Okay, so here what will happen? More delta, and it is decreases to less delta. Okay, according to the color variations. Next one, concept of minimum deviation. Concept of minimum deviation. We are going to speak about minimum deviation. Below, right? Conditions at which delta minimum occur. Minimum deviations were in a case. In what are the conditions at which the minimum deviations will occur? When you can take a minimum deviation, I is equal to E. I is equal to E. Second one, R1 equal to R2. If any such conditions are there in the question, then you have to take it as minimum deviation. I is equal to E, R1 equal to R2. The refracted ray inside the prism, is parallel to base of the prism. The refracted ray inside the prism is parallel to base of the prism. Understood? Then below, right? Variation of next heading, variation of variation of deviations with angle of incidence. Okay, then listen to the board, then we will write after some time. Okay, if you are plotting the graph of delta with respect to the angle of deviations, you remember the graph, right? What's the graph? The graph, first of all, the graph is not a parabola. It is tilted more towards right. It is tilted more towards right. It is not like this. This is not correct. It is tilted more towards right side, tilted more towards right side. That's the meaning. Graph is look like this one. Delta we are plotting. If lab we will do the prism experiment. We are changing the angle of incidence. We can measure the deviations. So if you do that for any prism, you will get a value. So minimum deviation means a delta would fall in the lowest value. This lowest value is called delta minimum. Okay. Normally, entrance this area one questions will come. Why? Because students will take this area as a very simple one and they will leave it, but a tricky question will be there. What that indicate is that this is a delta minimum value of this one. But other than the minimum value, what is the conditions for minimum value? First we will go there. I is equal to E, R equal to. So I know delta minimum is equal to I is equal to E. What is a general equation? I plus E minus A. Correct? So I is equal to E. So I can written as 2I, for example, 2I, E is equal to I, 2I minus A. But A in additionally, A is equal to R1 plus R2 is equal to R, for example. Okay, R1 plus R2 and R1 equal to R, R2 is also equal to R because R1 and R2 are equal, and A is equal to 2R. This we can return like this. So delta minimum deviation 2I minus A. This is one equation we can write. Another one, delta minima is equal to 2I minus A means 2R. So we can write like this also. Okay, these are the expressions for delta minimum. But one speciality in this graph is like, if you are drawing any other lines, for example, I am drawing another line like this, for example, then this line which is falling over will be here, and this is my minimum point, right? This is my minimum, and this is a minimum point, and this is a first cut, and this is the next cut. Okay, so for example, for this delta value, there are two angle of incidence. This is the I-axis angle of incidence. This is I1 angle of incidence, and this is I angle of incidence, for example, and this I1 and this I1 are not same. This is I2. Why? Because the distance from the minima to this point and minima to this point is different size, different length. Which means if this is x1 and this is x2, I can say x2 greater than x1. I can say x2 greater than x1. Indicate, for example, in a prism, normally we are learning like incident ray coming after refractions, it's going out like this one, right? Here we will do the angle of incidence. This is called angle of incidence, and this side is called angle of emergence. Actually, what is this? This I. Okay, and at the same time you have an I2. This I2 is actually equal to this emergence. I2 is actually equal to emergence. So incident and emergence are always not equal. But if now you are looking from the left side, okay, so instead of you are looking from the left side, if you are looking from right side, you can see this is an incident ray and same path will follow. This is a refracted ray. The same path will retrace. If you are giving an incident ray like this, the same way it will get refracted. So then here E become I and I become E. Opposite volta. So both are possible. Two sides possible. You will get 2 delta. You will get 2 values of delta. You will get 2 values of delta. This one is for incident, another is one for emergence. Both are not equal. Both are unequal. Okay. For example, if the delta minima is given as, for example, a 30 degree is given to you in the question. Suppose it's a numerical question, and 30 degree is given to you. Then they will give you a value of I1. I1 they say like maybe for example equal to 40 degree. Okay, anyway it is less than 30, right? It is towards the delta minima is 30. So delta corresponding to I1 is a higher value. Okay, and I1 value, for example, it is given like not delta minima. I is given like a 30 degree. Then what is I1 will come? A lesser value. A lesser value means maybe I'll take like 24 degree. So what is the difference between these two? 30 minus 24. X1 will be equal to 6 degree. X1 will be this angle is 6 degree. This piece is 6 degree. But then they will ask you, and this is given as delta 1. Okay. Then this is given as delta 2. And corresponding to delta 2, what is the angle of incidence? That is a question. So what you have to do? You know this difference is how much? 6 degree. But you are not supposed to calculate the same difference to the right side. You have to take an option which is greater than 6 extra. Here is a minimum 6. You know x2 is greater than x1. So here you are subtracting 6. But if you are adding 6 will be here, what you will get? 36 because x2 is greater than x1. So 36 any options will be the correct. For example, in the option it is given 38 degree, then it's a correct answer. Options will be give you like, for example, 24 degree, I2 is 24 degree, I2 is 30 degree, I2 is 36 degree, I2 is 38 degree. So what is the right answer? 30 degree. Here it is 6 difference. So right side it is not 6 difference. Is greater than 6. Greater than 6 വരുമ്പോൾ 30 plus 6 എന്ന് പറയുമ്പോൾ 36. മേലെ ഇരിക്കുന്ന ഒരു നമ്പർ ഏതാ 38. So that is the only possible answer there. Likewise you have to answer. Understood? So which means from the minimum deviation, if you are taking any left point, there is a difference. That difference and the right side differences are not equal. അതുകൊണ്ടാണ് ഈ ഗ്രാഫ് പരാബോള എല്ലാം സപ്പോസ് ഇഫ് ഇറ്റ് ഈസ് എ പെർഫെക്റ്റ് പരാബോള, then if you are drawing one line will be here, you will get these 2 points. These are, if this is 5 centimeter, this is also 5 centimeter, exactly 5 centimeter. So the minimum deviation with the angle of incidence is a parabolic graph. Other statement is wrong. Okay, which of the following statement is true? Which of the following statement is false? Okay, the angle of incidence with the deviation graph is a parabola. Parabola, it's not parabola. It is not a parabola. Parabola is difference equal. This difference equal. So this means it's not a parabola. It's a right tilted structure. It's a right tilted. Right side tilted. That's x2 higher, x1 lower reasons. Understood? So you can draw this graph and then mark these values as examples. Write the equations, whatever necessary. Write it in an ordered way. You understood, right? Then write these points also there. If I1 is the angle of incidence, then I2 is the angle of emergence, and vice versa. Okay. I1 not equal to I2. I2 greater than I1 always. If I1 is the angle of incidence, I2 is the angle of emergence, and vice versa. I1 is not equal to I2, I2 is greater than I1 always. Or I can say this is equal to emergence angle always greater than incidence angle if you are taking from left to right. Then write one question. For I is equal to 30 degree, for I is equal to 32 degree, for I is equal to 32 degree, angle of deviation is minimum. Angle of deviation is minimum. For I is equal to 32 degree, angle of deviation is minimum. Find the angle of emergence. Find the angle of emergence at 25 degree. At 25 degree. Four options are there. Option A 39 degree. Option B 38 degree. Option C 37 degree. Option D 41 degree. At I equal to 32 degree, we have delta minimum. That is given in the question. Draw the graph. Immediately draw the graph, because with the graph only we can analyze. You have a graph and the delta minimum is occurring at I is equal to 32 degree. Correct. And we have an angle of delta at angle of incidence is what? 25 degree. 25 degree കൊടുത്തു. I1 25 വന്നു. I എவ்வளോ വന്നു? 32. അതിന്റെ ഡിഫറൻസ് എவ்வளോ? അതിന്റെ ഡിഫറൻസ് എவ்வளോ? 7. അപ്പോൾ റൈറ്റ് സൈഡിലുള്ള ഡിഫറൻസ് 7 കൂടെ അധികമായി എടുക്കണം. അപ്പോൾ 32 പ്ലസ് 7 എടുത്താൽ 39. 39 വരാതെ 39ക്ക് മേലെ ഹയർ ഓപ്ഷൻസ്. 41 is the right answer. 41 is the right answer. Okay, you have to pick like that. Next heading, relation between refractive index n and delta deviation. Delta equal to n minus 1 into a. Just remember this. Next heading, refractive index of prism. Refractive index of prism, n equal to sine of a plus delta minimum divided by 2 whole divided by sine of a by 2. Both will have a derivation, but it is not required. Again, it is some triangle, some calculation, similar triangle concept, parallelogram law, that things we are taking and calculating the steps. Then the next heading. This one, direct questions will come this area. We will do some questions later. Anyway, it is direct. A value is given. Delta minima you have to find out, and sine of a by 2 is calculated. Refractions through a spherical surface. Refraction through a spherical surface. Refractions through a spherical surface. Refractions through a spherical surface. What this is indicate? If it is a glass. Okay, this is not a convex mirror, just a glass. Okay, and the completely this side is a glass medium, and this is like a principal axis. And if an object is placed, will be here. This will undergo refraction, and an image will be formed somewhere. And the object distance from the pole is u, and the image distance is v. Correct? And the image distance is v. Then there is a formula which is connecting between all refractions through it. This surface will have some radius of curvature called r. Okay, so what is the formula for this one? First draw the diagram. U, v mark. Idana incident ray, idana reflected ray. Here one formula is applicable. That formula is n2 divided by v minus n1 divided by u equal to n2 minus n1 divided by r. R is the radius of curvature. Depends upon the question. We will do some questions for this case. n2 divided by v minus n divided by u equal to n2 minus n1 divided by r. We'll do some question, then it will be clear. All the formulas are the prism, the refraction through a spherical surface. Okay, again idum ella triangle edukum simplify angane derive edu konduvarunnaanu, but it's not needed. Okay, so right echo. Find the position of the final image with respect to pole. Find the position of the final image with respect to position of the final image with respect to pole. n2 equal to 1.5, n1 equal to 1, and object is placed will be here at a distance of 30 centimeter. Object r equal to 10 centimeters. So this is, we know it's a refraction through a spherical surface. Right side is a glass, left side is air. Correct? So we have to apply the formula. What is the formula? N2 divided by V minus N1 divided by U equal to N2 minus N1 divided by R. N2 is a second medium, 1.5 divided by V. Yes, N1 is 1 divided by U. So this is the direction of incident ray, right? Anyway, so we are measuring the distance towards left side against the direction of incident ray. So we'll put minus 30 is equal to N2 minus N1, 1.5 minus 1. Radius of curvature we are measuring along the direction of incident ray. So it is positive, so it is 10. Now we have to simplify this. 1.5 divided by V plus 1 by 30 is equal to 1.5, 1 by 20. 1.5 divided by V is equal to 1 by 20 minus 1 by 30. 1.5 divided by V is equal to 30 minus 20, then a 10 divided by 600. So 10V is equal to 600 into 1.5. V to 600 into 1.5 divided by 10. Cancel. 6 into 15 varum 90. Got it? Yeah, 90 what directions? Positive 90. So image is in this one. Okay, at a distance. So image will be formed somewhere here, and this is at a distance of 90 centimeter towards right side because it is positive. Below below right, if U and V have opposite sign, if U and V have opposite sign, but U kum V ko opposite sign alle, image is a real image. This is the way of identifying another way. If U and V are opposite sign, it's a real image. If U and V have same sign, then it's a virtual image. This is a shortcut to remember that. If U and V have same sign, then it is a virtual image. Okay, applicable only for refraction. Applicable both the above points. Both the above points are applicable only for refraction. This is an easy way to remember. If U and V have same sign, virtual image. Opposite sign, real image. This is only for refraction. So what about for reflection? This is the opposite. Next point is in case of reflection. That mirror lo varu. If you analyze, you can see. In case of reflection, U and V, same sign, real image. Real image arikku. Correct alla? Anga U negative varumba image left il varum. Correct. Then next one. If U and V opposite sign, it is virtual image. In case of reflection or in case of mirror. Next question. Find the position and nature of image. Find the position and the nature of image. Nature of image means real or virtual. Okay. You have to find out whether it is real or it is virtual. Glass, water, 4 by 3, n equal to 4 by 3, n equal to 3 by 2. Object is placed at a distance of 20 centimeters away. This is a point at center of curvature at 10 centimeters away. Settings in the video. Virtual image. Run to same side. What's the answer you got? V equal to minus 30. Minus 30. U is also minus. So it's what type of image? Virtual image. Both are having the same sign, so it's a virtual image. Correct? Yes. We'll go to the next question now. Find the position of image. Find the position of image from O. From O. Glass into the 3/2, water into the 4/3. Already you know, right? R equal to 10 centimeter. An object is placed at a distance of 20 centimeters. Now it's a circle, it's a glass bowl. Object will be here. Find the position of image. So what is the idea will be here? Here it's a refraction through a spherical surface. Here you will apply our formula. N2 by V minus N1 by U equal to N2 minus N1 into R1. That you will give rise to what is called a V. You will get a V, right? That V will act as an object for the second one. Okay, then again you will apply the formula will be here. Then again you will find the next V. O is a center, sorry. O is a center point. O is a center point. First you apply it, adin V kandupidikum. That V is the U for the next surface. Okay, we'll see what you are getting. Do it step by step, sir. Then got it. answer. You will get it as 90 from the center. Okay, first case V kandupidikkuma how much you will got? V is equal to minus 13 varum. Second case we will go minus 13 from here it is 30. So from here extra 20, diameter 20. So this side formula apply U equal to minus 50. R equal to, R is left side, R. So R equal to minus 10. With a direct formula. That second case N2, N1. So second case N2 is equal to 4 by 3, N1 equal to 3 by 2. N2 minus N1 corner median second N2. Then directly substitute in the formula for the second case. N2 divided by V minus N1 divided by U equal to N2 minus N1 divided by R. N2 is 4 by 3 divided by V minus N1 3 by 2 divided by minus 50 is equal to N2 4 by 3 minus 3 by 2 whole divided by R minus 10. And simplify that, you will get V is equal to minus 100. Minus 100 means the final V is from here, it is 100 centimeter. From O, how much it will come? 90 centimeter. So the final image will be here. Got it? Next question. This you can try as homework. Find the position. I know already one will be there, right? This find the position and the nature of the final image. Find the position and nature of the final image. Diameter 10 centimeter. This is a glass medium and this is an air medium, like this. This you can try. Air medium, glass medium, air medium. But what is the only difference you have to take in care? Here diameter is 10 centimeter. The only difference is object it's not given. So object is at infinity. Object is infinity. And I will give you that try. In case if you are not getting, please come back to me. Final image at a distance of, answer idana, final image at a distance of 2.5 centimeter from second surface. From second surface. Second surface 2.5 centimeter plus 2.5 which means right side. Okay, plus 2.5 centimeter from the second surface, which means what side? Right side. Plus right side. Towards even 2.5 centimeter final image. Okay, try it today itself after the lunch. Okay, then fine, we'll see on next class.